This is the fifth lecture in our preamble for differential equations. We want to make sure that we have a nice, good review here going. And today we are going to be discussing the complex number system. And we're going to just do basic stuff with these. These are very important in differential equations, and you're going to see in high school when you study these, you don't really, and even in college algebra, all you get is that they're solutions to quadratic equations, and they don't get a lot of respect. But it's these numbers that really make technology what it is today. If it weren't for these numbers being in use and applied, a lot of things, physics and sine waves and things like that wouldn't be modeled as they are in calculus without these numbers. So let's take a look at what the complex number system does. Is it extends the real number system. And what I mean by that is the real numbers are a subset of the complex numbers. Okay, so the real numbers are a subset of the complex number. So every real number is also a complex number. But what separates the complex number is that we have this imaginary unit I. I is the imaginary unit, and it is not a real number. It's imaginary. It doesn't really exist. It is the square root of -1. The square root of -1. So let's find some powers of I and see if we can find a pattern here, because we're going to do arithmetic with these numbers, and that's important. So if we take I squared is the square root of -1 times the square root of -1. And we learned in algebra that if we take the square root of the same thing, multiply it, we multiply two square roots, we multiply what's underneath, but that doesn't apply here. We can't say that this is the square root of +1, which it's not. It is just -1. So I squared is -1. So it kind of contradicts some of the properties of square roots, but if you square a square root, you get what's underneath there. That's going to be -1. This is one of the few squares that are actually negative is I squared. So what about I cubed? Okay, so I cubed is I squared times I. And we said that I squared is -1. And I is the square root of -1. So I cubed is negative I. I cubed is -I. So let me write these down. This is I squared is -1. Oh, no, yeah. I cubed is -I. And what is I to the fourth? Well, we can write I to the fourth as I squared times I squared, which is -1 times -1, which is +1. So this is +1. All right. So I to the fifth is I to the fourth times I, which is just I. I. That's a crappy I, but that's an I. And then I to the sixth is going to be -1. Why? Because we're starting to see a pattern here. Because we're going to, if we find I squared doing the same thing we found I to the fifth with, I to the sixth is going to be -1. I to the seventh is going to be -I. And I to the eighth would be I to the fourth times I to the fourth, right? Which is 1. So what we see here is that the complex powers are periodic. The complex powers are periodic. Now, what separates, these are just the imaginary numbers. What makes the complex numbers is that, let's just say a complex number z is in the form of a plus bi. And sometimes you see this written as ib. They mean the same thing because complex numbers are commutative, which means you can multiply them in any order. Where a and b are real numbers. So a and b are real numbers. And we call a the real part. Just A. A is the real part, and B is the imaginary part. Not BI, B. So the coefficient of the I is the real part. And we can do arithmetic with these. So let's look at some examples, mainly by combining like terms. So I'm going to use these same two numbers every time. We're going to take 4 plus 2i, and we're going to add it to 8 minus 3i. And all the arithmetic we're going to do is going to be with these two numbers in this example, in these examples. So we're going to add, subtract, multiply, and divide them. Okay, so if we're going to add these, we just combine like terms. We add the real parts, because this is the same as 4 plus 8 plus 2 minus 3i. We just combine those coefficients there. So 4 plus 8 is 12, and 2 minus 3 is negative 1, so we could say that that is 12 minus I. Let's subtract the two. Subtraction would be the same way as if they were polynomials. So that's going to be 4 plus 2i, and then this negative changes the sign of both the signs there. So it'll be minus 8 plus 3i. 4 minus 8 is negative 4, and 2 plus 3 is 5i. So this would be negative 4 plus 5i. And addition's associative too, so you could also write that as 5i minus 4. But generally, it's in this form a plus bi. This is also accepted, but not it's frowned upon. Let's just say that. Okay, let's use these rules to multiply. And when we multiply, we're going to multiply 4 plus 2i times 8 minus 3i. Okay, so we can use the FOIL method to do this, but I'm going to use the distributive property because some people see this a little easier. It's going to be the first term in this times the second, right? This first term times the second factor plus the second term in the first factor times the second factor. Okay, now, so, or you could FOIL it however you want to do it. I'm just doing this because it shows work a little easier. So we're going to distribute this 4 across. So 4 times 8 is 32, and 4 times negative 3i is negative 12i, and 2i times 8 is plus 16i. Now, here's the kicker. I times I is I squared. I squared is negative 1. So when we multiply this, we'll have 2 times negative 3. 2 times negative 3 times negative 1, because I squared is negative 1. So this is actually plus 6. Okay? Plus 6. And 32 plus 6 is 38. And 16 minus 12 is 4i. So this is 38 plus 4i. Okay, so the next thing we're going to look at is we're going to define a new number called the complex conjugate. Okay, and it is denoted by, if z is the complex number a plus bi, the complex conjugate has a bar over it, and it's the same real and imaginary parts. The only difference is this sign is changed. Now, what's important about this is that z times z bar is always a real number. It's always a real number, and let's prove that. Okay, because look, it's the difference of two squares. Okay, so that means these two are going to cancel out when we FOIL it. Let's say this is a plus bi. We'll just multiply these two here. A minus bi is equal to, okay, so let's find a formula for this. This would be a times a plus b, a minus bi, I'm sorry, a times a minus bi plus bi times a minus bi. So this is going to be a times a is a squared, a times negative bi is minus abi, and then here this is abi, so it would be plus abi, and this will be minus b squared I squared, and I squared is -1, so this becomes plus b squared. So it's b squared I squared, negative b squared I squared. No. Yes. Yeah. Negative b times b will be b squared. Negative b squared. Oh, you can't even see that. Negative b squared I squared. Negative b squared I squared. That's, let me kind of put this over here, which is positive b squared. These cancel, so this is a squared plus b squared. So anytime you multiply by a complex conjugate of a number, you get a real number, and it's the sum of the square of the real part and the imaginary part. Let's look at an example here. Let's say we have, let's find both we had 4 plus 2i, right? Times 4 minus 2i. So this is going to be 4 times 4 is 16 plus 2 times 2, which is 20. Okay, so if we multiply that by the complex conjugate, we get 20. What about the other one, 8 minus 3i? So that would be 8 times 8 plus 3i. And that's going to be 64 plus 9, right? 8 times 8 is 64, and then the square of the imaginary part is 9, and 64 plus 9 is 73. Okay, so why do we want to do this? Well, we can do this as a form of division. So when we divide, let's say we're going to divide these two numbers, 4 plus 2i divided by 8 minus 3i. It's kind of like rationalizing a square root. We're going to multiply this by 1, but 1 is going to be the form of the complex conjugate. So the complex conjugate of 8 minus 3i is 8 plus 3i. So this is going to be 8 plus 3i down here. And now we can multiply this. We already did, well, we kind of did this. This sign was different, so let's multiply it again. 4 times 8 is 32 plus the outer is 12i and the inner is 16i, so 12i and 16i is 28i. And 2 times 3 is 6, but I squared is -1, so this becomes -6. All over this complex conjugate, which we just did right here, which is 73. So this is 26 plus 28i divided by 73. But most of the time, this is not the proper way to write the answer. Most people would write this as 26 over 73 plus 28 over 73i. Okay, so that's a basic review over complex arithmetic. I appreciate you watching. The next video will be coming up in the next few days, and I hope to see you there. If you have any questions, please comment, subscribe. Check us out on Facebook at facebook.com. Facebook.com/math-based tutoring. I offer affordable tutoring to include differential equations and many other math subjects as well at affordable rates. I appreciate you watching, and we'll see you in the next video.